Hello everyone, I am Bireshwar Roy. I am currently pursuing my fourth year PhD in the Department of Physics, Indian Institute of Science, Bangalore. In this NPTEL GATE Physics course, I will be discussing some previous year's GATE Physics questions and try to solve them with proper explanations. This question was asked in the GATE Physics paper 2020. This is a MCQ type question having 2 marks, and the topic of the question is electromagnetism. The question is, a charge Q moving with uniform speed enters a cylindrical region in free space at t equals to 0 and exits the region at t equals to tau, according to the figure. Which one of the following options best describes the time dependence of total electric flux phi is a function of t through the entire surface of the cylinder? So there are 4 options given. We have to choose the correct options which describes the graphical plot of phi as a function of t in a proper manner. So let us see how to solve this problem. So it is given that a charge q moving with uniform speed enters the cylindrical region in free space at t equals to 0 and exits the region at t equals to tau. So this is our cylinder. So we are dividing the region into 3 parts. So region 1, region 2 and region 3. So charge is initially at region 1 in the free space. So it is coming towards the cylindrical region and it enters through this surface of the cylinder and it enters the region 2. Then it travels through the cylinder for the time interval t equals to tau. Then again it exits and enters the region 3, which is free space. So we have to find the time dependence of total electric flux as if phi as a function of t through the surface of the cylinder. So that's the surface of the region 2. Now we'll consider the Gaussian surface for this problem same as the cylindrical surface. When the charge q is inside the cylindrical Gaussian surface, that is in the region 2, according to the Gauss law of electric flux, the electric flux is equals to charge enclosed by this cylindrical Gaussian surface divided by epsilon naught, where epsilon naught is the permittivity of free space. Now, in this case, this q enclosed, that is charge enclosed by this cylindrical Gaussian surface, is time dependent. Because this charge is moving, so the charge is inside this cylindrical Gaussian surface for the time interval 0 to tau. So our q enclosed is equals to q for this time interval 0 to tau, otherwise it will be 0 in region 2. So the time dependent electric flux will be q enclosed by epsilon naught, that is q by epsilon naught for the time interval 0 to tau and 0 in otherwise. So the plot for the electric flux phi as a function of t, it will be looking like this. So our electric flux is constant, that is q by epsilon naught for the time interval 0 to tau, and it will be 0 after t equals to tau. So it will be option D, that is the correct option for this question. So we have discussed this problem and we found that option D is the correct answer for this question. This question was asked in the GATE Physics paper 2020. There is a numerical answer type question having 2 marks and the topic of the question is quantum mechanics. The question is, consider the Hamiltonian H cap, that is divided into 2 parts, equals to H naught cap plus H dash cap, where H naught cap is 3 cross 3 matrix, that is E00, 0E0, 00E. So it is a diagonal matrix. And H dash cap is the time independent perturbation given by H dash cap equals to this 3 cross 3 matrix, that is 0 k 0, k 0 k and 0 k 0, where k is greater than 0. If maximum energy eigenvalue of this H cap is 3 electron volt and corresponding to E equals to 2 electron volt, then the value of k rounded off to 3 decimal places in electron volt is, so we have to find the value of k for this matrix. So it is given that H cap equals to H naught cap plus H dash cap, where H naught cap equals to this matrix 3 cross 3 matrix, that is E00, 0E0 and 00E. Now the time independent perturbation H dash cap matrix is given by 0k0, k0k and 0k0, where k is greater than 0, that is given in the question. So total Hamiltonian is H naught cap plus H dash cap. So if we add these two matrix, then we will get this. So after adding those two matrices, we'll get the total Hamiltonian H cap equals to EK0, KEK, 0KE, this 3 cross 3 matrix. Now this is a 3 cross 3 matrix, so if we want to find the eigenvalues for this matrix, we will get 3 different eigenvalues. So let the set of lambda be the eigenvalues of the total Hamiltonian H cap. So we know how to find the eigenvalues, so we will not discuss this in this question. We will directly go with the mathematical formulation for the to find the eigenvalues. So to find the eigenvalue, what we will do, we will take this determinant, that is E minus lambda k 0, k E minus lambda k, 0 k E minus lambda, and this determinant is equals to 0. So to find the determinant, what we will do, we will just take this component and multiply it with this determinant 2 cross 2 determinant, that is E minus lambda k, k E minus lambda, and similarly for the other components also. So after doing that, what we will get, E minus lambda times E minus lambda whole square minus k square in the parenthesis minus k times this term in the parenthesis, that is k into E minus lambda minus 0, and that is equals to 0 here. So from the previous slide, what we obtained, that is E minus lambda times this term in the parenthesis, that is E minus lambda whole square minus k square times E minus lambda, that is equals to 0. So we can take E minus lambda common from this whole term. So we'll get E minus lambda times E minus lambda whole square minus k square, and again we'll get a minus k square. So that will give minus 2k square, and that is equals to 0. So from this equation, we can get either lambda equals to E, or this term, that is E minus lambda whole square minus 2k square equals to 0. So E minus lambda equals to plus minus root over 2k. So lambda equals to, that is E plus minus root over 2k. So we obtained 3 eigenvalues for the total Hamiltonian H cap. Those are lambda equals to E, E minus root 2k, and E plus root 2k. Now it is given in the question that our k value is always positive, that is greater than 0. The maximum energy eigenvalue of the total Hamiltonian H cap is E plus root 2k, that we have obtained from the eigenvalues of the total Hamiltonian, and that is equals to 3 electron volt, that is given in the question. Also given E equals to 2 electron volt. So we will put this E value in this equation. So what we will get, 2 plus root over 2k equals to 3. So k value is 3 minus 2 divided by root 2 electron volt, that is 1 by root 2 electron volt. So our k value is 0.707 electron volt, that is rounded off to 3 decimal places. So this is the answer for the k value. So we have solved this problem. So what we did in this problem, we have just added these two matrices and we found the eigenvalue for the total Hamiltonian H cap. Then we equated the maximum eigenvalue with the 3 electron volt, and also we know the E value, that is the eigenvalue for the primary Hamiltonian H naught cap. By putting that in that equation, we found the K value for the perturbation matrix, and the K value rounded off to 3 decimal places in electron volt is 0.707. That is the answer for this question.